In today's video, I'm going to be upgrading my smart home system using this little Power over Ethernet Zigbee gateway. For almost the entire time I've had my self-hosted smart home, I've been running Zigbee to MQTT on a Raspberry Pi, and that bridges all my Zigbee devices over to MQTT, where I then control them from Node-RED and Home Assistant. And that Raspberry Pi has a Power over Ethernet hat on it, and hides away in a hallway cupboard and connects the Zigbee devices using a sawn-off Zigbee USB dongle. However, I kind of want to get away from having lots of little individual Linux devices all over the place managing my smart home, and instead I want to get everything migrated onto my Proxmox server. So that server is currently running Home Assistant, Node-RED, and all the other components for my smart home in virtual machines. So all I really have now is this Raspberry Pi running Zigbee to MQTT. And ideally I want to get rid of that and have Zigbee to MQTT running on my server as well. This has a few advantages. It just means everything's running in one place. I can easily back the VMs up, I can snapshot them. If there's ever a problem, I can get in on a sort of KVM console. Whereas with the Raspberry Pi, I've had a few issues where, for example, I hadn't set the log rotation up correctly, and the SD card filled up with all the logs from Zigbee to MQTT, and the whole machine went down. And I couldn't even SSH in, I had to literally unplug it, plug a monitor, keyboard and mouse in, and get in and clear the logs out. If that had been on a virtual machine, it would have been a lot easier to deal with. So yeah, that's what I want to do. However, moving Zigbee to MQTT onto my server isn't completely straightforward because of that USB dongle. Because to connect to Zigbee devices, obviously, you need a Zigbee adapter. Now, of course, one of the options I could do would be plug my Zigbee dongle into my Proxmox server and pass that USB device through to the virtual machine. Now, in my setup here, that would probably work, but it's not really something I'm overly happy with doing because, sure enough, my server does run in my office, so it runs quite near some Zigbee devices, so the USB dongle would probably be okay. But for a lot of people, their servers are going to be away, hidden in garages, basements, cupboards, far away from Zigbee devices, potentially in big metal racks that would block the Zigbee signals. So I don't really want to be relying on having to have a Zigbee dongle plugged directly into my server. It also means you have to mess about with USB pass-through, and if you wanted to migrate that VM to another host, you'd have to move the dongle. Just not really what I want. So instead, I set out looking for a Zigbee adapter that could run over the network, ideally without much faffing or different firmware and things like that. And that's when I came across this, which is the Zigbee, or not Zigbee gateway, it's the HamGeek Plus PoE from a brand that seems to be called HamGeek or HamGeek. Can't quite make the font out, but yeah, that's the sort of brand there. And this is a really inexpensive Zigbee adapter that runs over the network. It supports PoE, so you can power over Ethernet, you don't need to have a power supply for this. And the firmware on this out of the box is designed for connections to Zigbee to MQTT and ZHA within Home Assistant. So unlike most dongles of this sort of form factor that'll run some sort of cloud-based firmware that'll connect them to a cloud or something like that, and you might be able to flash custom firmware on, but you've got to deal with all that, this device completely out of the box will allow me to connect directly from Zigbee to MQTT to this hardware using its stock firmware. So that looks like a really interesting device. So what we'll do in this video is we'll get this thing, first of all switch it on, take a look at the interface and set it up. I'll then migrate my existing Zigbee to MQTT setup to point to this instead of using the USB dongle. I won't bother migrating Zigbee to MQTT onto my server at this point, that's just way out the scope of this video. But once I've got this working with this connected to Zigbee to MQTT on the Raspberry Pi, I can then go away after this video and get Zigbee to MQTT migrated onto my Proxmox host. In fact, I might even migrate it into Home Assistant directly as a Home Assistant add-on, that might be even better. And then once we've done that, once we've got it working, we'll then pop it open and take a look at what's inside. So first of all, let's take a look at the hardware. So here it is, it's a fairly neat little white device. I think there's a white and a black one. Not really much to note, a few LEDs on the top for status. And on the back you can see all the connectors. We have the antenna here, which is quite a large, decent looking antenna. It's not like a little rubbish one, which is good. A button for changing modes and resetting and things like that. A USB-C connection, which you can also use to flash firmware, or you can power it over this if you're not using PoE. And then the Ethernet port, which also supports PoE. And now if you look at the model number, it's the HamGeek Plus PoE. And there's a few different versions of this. So they all come under the HamGeek model name, and this is the Plus model, and it's the PoE model. They do both the Plus version and the non-Plus version. Essentially, it seems as though the Plus version is just an updated model. So it's got a more powerful Zigbee chipset, a slightly newer version of that. It's got a few different, few more features, and it seems to have a potentially different operating system. I think the firmware is newer as well. So I decided to go for the Plus because it seems to be the latest and greatest and newest version. And then with both the Plus and the non-Plus version, you can get a PoE version or a non-PoE version. So just be careful if you're buying this, don't just assume that something that looks like this is PoE. You do need to explicitly go for the PoE version if you want to use the PoE functionality. On paper, the specs of this look pretty good. We'll take it apart later and properly take a look at the hardware, but according to the datasheet, it's based around an ESP32 microcontroller, so that's the main processor. And for the Zigbee chipset, the Plus model I have here uses a Texas Instruments CC2652P7. The non-Plus version uses the original CC2652P, so it's the P rather than P7. And this is essentially the same as what I have in my Sonoff dongle. The Sonoff dongle I have has a CC2652P as well. And because that Sonoff dongle absolutely handles all devices I have perfectly, I know that this should be absolutely fine. If anything, because this is the P7, it's a slightly newer revision, a slightly more powerful version, it should be absolutely fine to handle all my Zigbee devices. And this is a contrast to when I initially set this system up. Because when I first set this all up, I cheaped out and used a CC2531 dongle, which is a much cheaper USB Zigbee dongle. They cost like £3, they cost absolutely nothing. But they have such little memory that they do actually really struggle. I had all sorts of issues where I'd say turn off all the lights in a room, and my rooms have lots of downlights, so I've got like 9 individual Zigbee bulbs in my living room. And you'd press the switch, and then all the bulbs would turn off individually, and there'd be like a delay between them all, and it was really obvious. Or you'd have like one bulb would stay on, or one bulb wouldn't turn on. It didn't work properly. So you definitely don't want to cheap out and use really low-end Zigbee dongles. So it's good to see that this has a high-end Zigbee chipset, so it should be able to handle a lot of devices. And according to the datasheet, the Plus model can support up to 300 devices, and the non-Plus can support up to 200 devices. Now, that's probably not an actual hard limit or really a target, it's kind of just a rough guideline, but it is good that this does use a really good Zigbee chipset, it's not one of the really cheap ones. And then in terms of pricing, obviously pricing will fluctuate, and I've put links in the description to this if you're interested in checking it out. On AliExpress, these are around about £35. You can also get them from Amazon, obviously you'll pay a little bit more for Amazon, but you get the convenience of getting quicker shipping. But yeah, for around about £35, that's a pretty good price for this. That Sonoff USB dongle I have is well over £15 usually on AliExpress and almost £30 on Amazon. So getting this, which has the same chipset and a whole Power over Ethernet infrastructure and the ESP32 and a lot more hardware in it, for £35 is pretty good. So yeah, that's hardware there. So that's enough rambling, let's test it out. So what I've got here is I've got an Ethernet cable, it's connected up to one of my switches. This is a PoE switch on the other end. So we plug that into the back of the device, we should see it should power on. So the lights are quite dim, they might not come out on camera, but you can see maybe that those LEDs are blinking as it starts up. And I think eventually the network lights will come on once it's started up and got a network connection. So yeah, there we go. So we have network LEDs on the back, so we're up and connected to the network. There's a solid blue LED on the top. So what I'll now do is I'll go and grab a laptop, find the IP address this has got on the network, and we'll connect to it. Okay, so we're now connected to the network. I've found the device's IP address on the network, and I've brought up the web interface. So I'll put a screen recording in, and we can take a look at it. So here we are in the web interface, and as you can see straight away, it's actually pretty detailed. So what we'll do is we'll quickly go through it and take a look at all the options. So on the home page here is just kind of like a sort of status page that sort of shows how it all works. We can go into the general page here and you can change different operation modes. So currently it's in LAN mode, which means it's connected to a wired network. You can connect it to a Wi-Fi network because it does support Wi-Fi, or you can set it to USB mode and use it essentially as if it's a Zigbee USB dongle. So if you wanted to use it as a USB dongle, you could. Various other options here around toggling the LED status and stuff like that, but that's not a huge deal. In the Ethernet section here, we can then see we can set up either DHCP or a static IP address. Now, for me, I'm actually going to set a static IP on this because Zigbee to MQTT is going to need to connect to this using its IP address. So if it's got a dynamic IP, that's going to be a problem. So I won't do that right now on camera, but I will set a static IP on this before I use it because I don't want that IP address of this device changing. Next up on the Wi-Fi page, you could set up a Wi-Fi connection if you wanted to, but you need to enable Wi-Fi mode as it says in the bottom right here, so I'm not going to go and do that. And then here we have the information for Zigbee to MQTT and ZHA, which is Home Assistant. So in here you can see you can set up the baud rate. So this is the baud rate between the Zigbee chipset and the main ESP32, because the Zigbee chipset is essentially a serial device, and that's going to connect over a serial port to the ESP32. So you can change the baud rate of that here, just sort of for the performance. So may as well leave that on the highest speed. I don't know why you necessarily need to ever drop that down, but you could. And then 6638 is going to be the socket port. So that's the TCP port you're going to connect to access the Zigbee dongle on this. So you can change that port if for some reason you needed to. And then what it does here that's really nice is it actually generates the config you would need for Zigbee to MQTT or ZHA. So as you can see here, this is the config for Zigbee to MQTT. So all it does is this is fairly standard config, except for the port, rather than specifying a USB device, you specify the IP address and port of this device. ZHA, again fairly similar, gives you the address you put to ZHA. And then for USB, this is the config you put in for, I think Home Assistant, is that for ZHA? Or something if you're using it as a USB device. This isn't something I've really used, but it gives you config here for, it looks like Zigbee to MQTT config, but it also talks about Home Assistant. I think this is the config for Zigbee to MQTT, and this is the config for Home Assistant. I'm not quite sure. I'm sure people will correct me, but it's nice that it actually generates the config here. It's really not hard to figure this config out. Of course, those applications do have very good documentation, but it is nice to have that in the interface here. Other than that, there's a section here for security. So what you can do is you can disable the web server when the socket's connected, so this web server will disable so you can't access this web interface. You could technically add authentication as well to stop anyone logging into this web interface here. And you could also enable an IP whitelist for the socket connection. So this is quite important because this device, out of the box, doesn't have any kind of security. So anyone could open up, anyone on your network that can access this device could access this web interface. And likewise, even if you lock the web interface down with a password, anyone would be able to connect to the port that connects to your Zigbee dongle and potentially play with your Zigbee devices. So with this, it's definitely worth setting up the security. So enable some sort of authentication on the web interface just so no one can open this up. And also enable IP whitelisting so that only your Zigbee to MQTT or ZHA IP addresses can actually connect to this device. Now, of course, you should really go beyond this and also set up actual firewall rules. This is a very weird, slightly off-brand device with weird firmware on it. I would never recommend running this on a safety critical network or even on your main LAN. And in my case here, this runs on an isolated VLAN that is dedicated to IoT devices, and this device can't even access out to the internet on this network. So I've kept this quite locked down. So I've also got additional firewall rules and stuff locking this device down even further, but it is really nice to have this functionality so you could actually lock it down on your local network too. So that's nice to have. Finally, there's a section here for system and tools, so you can change the host name of it if you wanted. Various options for restarting various parts of it, which is quite nice. You could potentially restart just the Zigbee dongle and things like that if you were having issues, but equally, you're probably going to restart the whole thing, let's face it. System tools here lets you do sort of firmware update, back up different config files, that kind of stuff there. And then finally, about just gives some more information. There's a Telegram chat for support. And as you can see, it's based on this sort of ZigStar firmware, so there is sort of open source firmware that this is based off of. Not quite sure how much they've adapted from the ZigStar firmware to make this, but yeah, that's the web interface. So what I'll do now is I'll go way off camera, I'll set this up with a static IP address just rather than having a DHCP IP, and then what we'll do is we'll take a look at how I'm going to put this into Zigbee to MQTT to tell it to no longer use my USB dongle and to use this device instead. And hopefully everything should just work, but we'll see if it's as easy as it seems. So let's go and see if this works. And we're back. So what I've now done is I've set a static IP address on the Zigbee coordinator, so now we can set this up in Zigbee to MQTT. As part of this, I did find one very slight bug, but really confused me for a while. So I'll just mention it just in case anyone does buy this. Is when I was setting up the static IP address, I put an IP address in, put the gateway in, and the subnet mask was already kind of filled, so there was nothing in the box, but there was a placeholder for 255.255.255.0. So when I saw that, usually when there's a placeholder in a box like that, you kind of go, okay, that's already going to be set to that, that's the default. So I was literally just lazy and just didn't type a netmask in and saved it. And then I got really confused as to why I couldn't access it, because my laptop is on my main LAN. This is on an IoT subnet, so I am going across subnets. And it turns out that when you don't specify anything in there, even though the placeholder, if I delete that out of there, you can see the placeholder does show 255.255.255.0. That won't actually set that net mask. So I had to then go in on the same VLAN, come in, or same subnet, come in and then set a net mask. And now I've set that net mask there, I can actually access a web interface across different subnets. So just like to bear in mind there that even though that looks like it sets that by default, it doesn't. You do need to type it in. But yep, we have that in there. So what we'll now do is we'll try and migrate Zigbee to MQTT to use this instead of the USB dongle. So if you look over here, I have Zigbee to MQTT pulled up. So this is my Zigbee to MQTT web interface. And as you can see in here, we have all my devices. So there's absolutely a ton of devices in here. There is a lot of devices showing as offline. These are all devices that I no longer have or more so don't have them actually powered on or connected right now. I'm quite bad for testing devices with this and then never actually clearing them out. So that these devices being offline isn't a problem. These are just ones that aren't actually, they don't exist right now. But as you can see, we have all my devices that I'm currently using all showing up in here. So what we now need to do is migrate this to use this device here instead of the USB dongle we're currently using. So what's quite useful is if we come into here, we can actually get the config we need. So we can go to Zigbee2MQTT here and get that config up. So that's the config we're going to want. So I'll pull up an SSH session to the Raspberry Pi that's running Zigbee2MQTT, and we'll update the config. So of course, depending on your Zigbee2MQTT setup, the config could be very different. On mine, it's just, this is how I've installed it. So in here, we have a configuration YAML file. And in here, we can see we have the serial port specified here. And currently, that is dev TTY USB 0, so that's the USB dongle. So all I'm going to do here is I'm just going to comment that out, like that. And then instead, we're going to specify the network. So we're going to specify port is TCP 10.114.3.10, and then the port is 6638, like that. It also wants us to specify the baud rate. I don't know if that's actually required, but we will just specify it anyway, just to be safe. So baud rate 115.200. And then the only other thing, that disable LED, I don't think is really important at all. And then the only other one here is I see this set output power to max 20 under advanced. I may as well set that just in case. So transmit power 20, just to put the exact recommended config that they're giving me in there. So set that there, just like that, save that config file. And what I'm now going to do is restart the Zigbee2MQTT service. So right now, everything is working perfectly fine on the USB dongle. So let's restart the service. I'll go and put my password in off camera. There we go. So that's now should be restarting that service. So we'll give it a little minute. It's a fairly old Raspberry Pi, so it will take a little while to restart because Zigbee2MQTT is quite resource intensive. So I'll let that restart and we'll come back when it's done and see if this works. So let's come back. As you can see down in HTOP, there's a bunch of node processes running, so that's actually restarting the application. And in theory, once this restarts, the web interface should come up and hopefully all my devices should come back online. If not, we'll have a bit of a problem. But we'll just let this restart and we'll see what happens. And we're back. So Zigbee2MQTT has now restarted. Had a little bit of an issue there just because it had some firewall rules that weren't set up right, so the two devices couldn't talk to each other, so I've tweaked the firewall, everything's now up and running. And now, so Zigbee2MQTT is now running back on the Raspberry Pi again. If we view the config, we can see we still have the configuration we had before, where it's now using the network serial port instead of the actual USB port. And if you look in the web interface on the Zigbee coordinator, you can see it now says socket client connected, yes, one connection. So yep, we're now connected. And now if we look over at the Zigbee2MQTT web interface, you can see we're back in, and all the devices that were online before are still online again. Actually, there's a couple that aren't, but I think that's just literally, I'll just need to go and physically restart those light bulbs. They're sometimes a little bit funny if the coordinator swapped out. I might need to go and restart some light bulbs, but generally speaking, it's up and running, and we've got devices connected to it. So what I'll now do, just to prove that this is definitely working, I'm going to go over to the Raspberry Pi, and I'm going to pull that USB dongle out of it, and then I'm going to bring that back over here, and there is the USB dongle that was in the Raspberry Pi. And if we come over here, we can see that the devices that were online are still online. Now, I will need to restart these bulbs, that's just obviously some light bulbs that we need powered off and on again, but yep, everything is back up. And now if I go into the other room, you're not going to see this because this is off camera and I really can't be bothered moving the camera, but if I turn the light switch on, yep, some lights are now turned on. So yeah, it's working. So of course, yeah, I'm going to have to go and restart some light bulbs. That's just a thing sometimes you need to do. But that was pretty seamless. Now, the only thing to bear in mind if you're migrating from one Zigbee dongle to another one, the Zigbee2MQTT, is sometimes you will need to repair all the devices. It really comes down to the sort of chipsets you're migrating between. If you're migrating between a similar Zigbee chipset, so in this case I'm migrating basically to the same chipset, just a slightly newer revision, you won't need to repair. But if you're migrating significant differences in Zigbee chipsets or Zigbee dongles, especially if you're going between different brands of chipsets, these are both Texas Instruments, but if you're going to a different non-Texas Instruments chipset especially, you will potentially need to repair all your Zigbee devices. So that's just something to bear in mind. But thankfully, I didn't need to do that here. All I'll need to do is go and power cycle some of the light bulbs, which is absolutely fine. And now finally, before we wrap this up, let's pop this thing open and see what's inside, just out of interest really. So take the antenna off, like that. And then on the bottom, there's just 4 little stickers over the screws. It's interesting because it's definitely not a complete, I mean, it's mass produced obviously, but it's, you know, the label looks quite homemade. It's not like a sort of super polished product. It does look like it's, you know, a relatively smaller production run type thing. So let's get these stickers out. No screw under that one. No screw under that one. Interesting. And screw under that one. So they've saved however much money it costs by omitting 2 of the screws. You know, saving all the money. But yeah, take these screws out. That one there and that one there. And now let's see A, what's inside, and B, how does this thing come apart? Right, I'm probably going to need to go away off camera and figure this out because I can't quite see how this comes apart yet. Okay, so I've been able to get a spudger under the edge here, and that's lifted up, so yep, the lid just comes out like that. And in there we can see the main PCB. So what I'll do is I'll go in a little bit closer, take a look off camera, work out what's here. I'm not going to go into too much detail and do like a full component analysis or anything like that, but I'll go in, take a look at this, and I'll come back with my findings. Okay, so here we are inside it, so let's take a look at what we found. So as you can see, it's based off of a lot of sort of pre-built modules. So the main module down here is this ESP module. So this is a standard ESP32 module. So it's standard expressive module. That's in there. That handles obviously all the main processor. That handles the web interface, the Wi-Fi, the Ethernet, all that kind of stuff is going to be running off this chip here. Then for the Zigbee connectivity, they have this module here, which is an RF star RFBM2652P4L or P41. Can't quite make that out. And that is the Zigbee module. So that contains that Texas Instruments SoC, and essentially it just takes that chip and puts it into more of a off-the-shelf, easy-to-use module. So that's all that is there. So that's the Texas Instruments chip is inside this module here, and this antenna comes off the connector on the back. Then there's just a couple of other minor things to note. So down here we have a CH340C USB to UART chip. So that's obviously, I imagine, I've not checked it, but I imagine that connects up to the ESP here, and then connects to the USB interface. So this would allow you to use a USB device and use this as a USB device either for a USB Zigbee dongle or to flash the firmware, and that essentially allows you to connect the UART on the ESP32 over a USB connection. And then over here you have this sort of transformer board on a separate board here. That'll be handling the PoE, and then here we have an Ethernet isolation transformer. So yeah, it's a pretty neat little layout. And then one other random thought I had, and I just decided to try it. I have a USB-C connection here, and this is plugged into a MacBook charger that needs USB power delivery. And if I plug into that, it powers up. So that's also really positive to see. Sounds silly, but it actually is working correctly with a USB-C cable. Because if you saw my video about a low-cost network tester, or the video I did about my HIC microthermal camera, it's quite common to get cheaper devices like this that have a USB-C port, but don't handle the power delivery negotiation correctly. So they just expect to get 5 volts on the USB-C port, and if you plug it into anything that's not a cheap charger, like any sort of USB-C power delivery type charger, they won't then power on. So it's good to see this actually is handling USB-C correctly and does actually power on from a power delivery capable charger. So that's really good to see as well. But yeah, seems like a pretty neat little layout. So let's get this thing back together and wrap this all up. So there you go. That was a look at the HamGeek HMG01 Plus PoE Power over Ethernet Zigbee coordinator, and how I'm using it to now connect Zigbee to MQTT to all my Zigbee devices over a network without having to use any sort of USB Zigbee dongles like I have here. And it works really well. The migration was pretty simple, and now all my Zigbee devices are connected through this rather than the USB dongle. Now, for now I'm still using the Raspberry Pi, but what I can now do is get Zigbee to MQTT set up on my server and simply migrate all the config and databases over to that, and it should just be a fairly seamless process to shut down the Pi, bring it up on the server, and all devices will stay connected to this. So yeah, I won't do that on this video because there's no real point, but yeah, actually works really, really well. So there you go, thank you very much for watching. If you're interested in buying this, I've put links in the description and in a pinned comment to both AliExpress and Amazon, so you can get it from either of those. But all that's left to say now is thank you very much for watching.